All right, so we're starting in on chapter 5 today. Understand where we're coming from. Chapter 5 is going to be talking about exponential and logarithmic functions. All right, this whole book goes through the family of functions. We did linear, we did quadratics, we've done polynomial functions, rational functions in chapter 4, and now we're working our way towards learning about exponential and logarithmic functions. To get through that, we're going to look at composite functions to start. All right, and this is something you guys have done before in Algebra 1 or Algebra 2. Okay, and if you can do substitution, you'll be able to do composite functions. Super easy stuff. So that's our goal for today. Okay, so a composite function looks like this. I've got f of g of x is how you read it. So another way to write that is f of g of x like this. Okay, g of x is my input. Normally we see f of x. Well, now it's f of g of x. G of x will be my input. Okay, versus this reads g of f of x. Or another way to write that is g of f of x like that. Okay, where f of x would be my input. Okay, so first thing we got to do is evaluate a composite. And I have two functions here. I have f of x is 3x plus 2. I'll use blue for that guy. And then g of x I have is 2x squared minus 1. Okay. So what they're going to ask us to do here is they want f of g of 4. Now I like to rewrite that like this. So f of g of 4. Well, to solve something like this, we want to get and work inside out. All right, we want to cover up the f, and we got to go and figure out, well, what is g of 4? Well, this is something we've done before. We've evaluated a function. We take our function over here. I've got 2x squared minus 1 for g. Okay, and I'm going to plug in this 4 right there. That's my input. So take a second. Please excuse my dear Aunt Sally when you do it. Please excuse my dear Aunt Sally. I've got 2 and then times 4 squared minus 1. Go ahead and square it first. Multiply by 2 and then subtract. Let me know what you guys get. Shout it out when you get it. So do your exponents first, then multiply, and then subtract. What do you guys get? Shout it out. If you need to, get a calculator. What's 4 squared times 2 minus 1?
31.
31. Very good. Okay. 4 squared is 16. 16 times 2 is 32, and then you subtract the 1. Awesome. Good job, Tommy. Well, now I'm going to use substitution. I'm going to plug it in. So I want f of 31. Okay. So it's kind of like two-stepper. I take my function, f of x is 3x plus 2. But instead of x, I put parentheses, and in the parentheses, I'm putting in my new input. The input is now 31. And then I simplify. 3 times 31 is 93. And then we add 2. And my final answer is 95. So if they ask me what f of g of 4 is, my final answer would be 95. And that's it. So if this is a number, then my final answer is going to have a number. Okay. They might ask you to do g of f of 2. All right, so I like to rewrite it like this. You don't have to. Whether you rewrite it or not, we're going to do the same thing. I cover up the first letter. First letter is a G. All right, so whether I do it here or here. So I cover up the G. And I got to find f of 2. So f tells me which one to do. I do the blue one. F of x is 3x plus 2. And now I'm plugging in 2 for x. That's my input. I got to see what I get. What's my output? 3 times 2 is 6. 6 plus 2 is 8. So f of 2 is 8. Everybody okay with that? Easy peasy? Now I take that and I plug it in right there. So I'm really finding G of 8. G function, coolest function ever. G, Mr. G, that's me. Plug in 8. Please excuse my dear Aunt Sally as you go through. 8 squared is 64, so I'll write that out. 2 times 64. And then we multiply that. 2 times 64 is 128, and then minus 1. Final answer we should get is 127. So when they ask me what G of f of 2 is, my final answer is 127. Okay. All right, all right. Do we have any questions on those two? I have two. If you guys have the note packet, I do have two more. Do we need to go over those two? Or can we bypass that? I don't want to waste your time. Give me a thumb. Where are we at? Do we need to see it? Give me a thumbs down because you need to see more. If you're like, nah, this is easy, give me a thumbs up so we can move on. Do we need to see more? I'm seeing mostly thumbs up. I don't see any thumbs down. No questions on this. All right, all right. I don't want to waste your time. Let's move on to the bottom. Okay. All right, so on examples 5, 6, and 7, they're basically asking you the same question, but now they're doing it graphically. Okay. So I've got f of x is the first graph. I'm going to do that one in blue. Okay. And then g of x is the second graph, so I'm going to do that one in red. Okay. So I got f of x and I have g of x. So I take a look. I've got f of g of 0. Okay. So I'll write that in colors here. So the first thing I got to do is I got to figure out what g of 0 is. Well, g of 0, right? Normally it's g of x. So this is my x value. You're saying, hey, x is 0. Hey, Mr. G, x is 0. What's the y value on the g function? Okay, so you're kind of like a pirate. You guys know pirates, right? Yar, yar, matey. So these are your two treasure maps. Yar. And X marks the spot for the treasure. So the G one says, yar, the red map, yar. And I want to find the treasure where X marks the spot at 0. So I go to 0 and I find what I got for the treasure chest. So I go up 1, 2, 3, 4, yar, and I got 0, 4. So they're asking you for the y value. The y value is 4. All right. Now this treasure map tells you where the next treasure is, right? So you open up the treasure map and they say, well, the next treasure is at 4, so you plug that in right there. So really the question is, what's f of that? What's f of 4? Yar. So again, f of 4, they're saying, hey, x is 4, what's the y value? F tells me what treasure map I look at. Yar, I look at the blue one. Yar, because that's f of x. So I count over 1, 2, 3, 4, and then up 1, 2, 3. That's the dot that I'm looking at. So that's the dot right there. That's 4, 3. So they give me the x value. They want the y value. The y value is 3. Okay. So final answer, what's f of g of 0? Looking at these two graphs, I should get 3 for my final answer. All right, so again, working inside out. They're giving you the x value. You got to find the y value. You got to do that twice. All right, so when I look at number 7, I'll jump to 7 here just so we can see it one more time. I'm doing g of f of negative 2. So my first question is, well, what's f of negative 2? So again, the idea is, well, x is negative 2. What's the y value? That's the question. So what graph do I go to? Do I go to the blue one or do I go to the red one? Do I go to F or do I go to G? Which one do you do? Roderick, what do you think? David, what do you think? Joey D. We go to the blue one. So I count over 1, 2 to the left, and I go down to the graph, and there it is right there. There's my treasure. My treasure is at -2, -1. So f of -2 is -1. Now I just plug it in. I plug it in right there. So this is really g of -1. Okay. They're saying, hey, the x value is -1. What's the y value? Question mark. So now I go to the red graph. Here's my treasure map. I got to find the treasure. Here's at -1. I count over. I go to the graph. That point right there would be the point on the graph at -1, comma something. Let's see. 1, 2, 3. Happens to be -1, 3. So my final answer is 3. Okay. Now your answer is not always 3. It just so happens these two that I picked are 3. Okay. Any questions with that? Do we need to see that again? Do we need to see example 6, or do you want to move on, y'all? What do you guys want? Do we need to see it one more time? No. Nobody's saying a word. Everybody's shaking their head. I don't need to see it. Okay, but I'm going to move on. Here we go. Got a few more. Now we start getting into the algebra. Let me know if you can't see this. Now we get into the algebra. It says for the given function f and g, find the composite functions. Okay. State the domain of each composite. So I've got f of x equals 3x plus 1. So if you don't have your notes, hopefully you're writing this stuff down. I don't know how you learn this stuff if you don't write this stuff down. G of x is x squared. Okay. Well, they want us to find f of g of x. Now, this time I have an x there, so my answer is going to have an x in it. They also want us to find the domain of this final composite function. So to do that, I always go through and make sure I know the domain of the original functions. Okay, this guy's a line. It's a type of polynomial function. There is no denominator like I see down here. There's a denominator, so those would be restrictions. I don't see any square roots, so I definitely have no restraints here. I have no denominator, no square root. I have no restrictions. So my domain would be the all reals, the fancy R. Okay. Same thing with this one. I have a quadratic here. I have a parabola, right? There is no gaps, holes, or breaks in a quadratic or a parabola. So your domain would be all reals, or you could write it -infinity to infinity, however you want to do it. I don't really care. I think in my math lab, it'll just be one of the options to choose with a multiple choice. So let's get started here. All right, it says f of g of x. So let me write my f's here. So f of g of x. Well, g of x is x squared. So I'm doing f of x squared. Well, the f function says I take 3 times my input and I add 1 to it. Okay, so if this was like 10, if this was f of 10, I would plug in 10 right there. But it's f of x squared, so wherever there's an x, I put parentheses, and in my parentheses, I put the x squared. So if there's a 10 here, I plug 10, I would multiply and simplify. Well, it's f of x squared, so I put the x squared in there, I multiply and simplify, and I end up with 3x squared plus 1 is my final answer. Again, when I look at this guy, there is no denominator, there's no square root, so your domain is that fancy R, the all real numbers. You got to be able to give me the domain of that composite. Any questions on how I got 3x squared plus 1 or my domain? Sometimes they're just super easy. So far, so good? All right, let's look at number 9. Now I'm doing g of f of x. So when I do g of f of x, I like to write this way. I just prefer how it looks. To me, this makes more sense. I'm doing my input is f of x, which is this guy. I got 3x plus 1. Okay. So I look at the g function. The g function says take my input and square it. Okay. So if my input was 3, I would plug 3 in here. I'd square it and I'd be done. Right? I would get 9. But that's not my input. My input is f of x. It's 3x plus 1. So I got to take 3x plus 1 and I got to square it. Okay? Well, it's been a while. What's that 4-letter F word you're allowed to say in math class? What can you say in math class? Foil. Foil, yeah, baby. Boom. So if you need to expand this out, 3x plus 1 and 3x plus 1, and then go ahead and FOIL that thing. Okay, 3x and 3x, that's 9x squared. 3x and 1 is 3x, do it again. Now I got 3x and 3x, that's 6x. And 1 times 1 is 1. Look at that. Again, we got a nice quadratic here. There is no denominator, no square root, no restrictions in the domain. So your domain is that all real numbers. If you want to write it like this, you want to write it out, all reals, you can do that. It's kind of whatever you want to do. You can do negative infinity to infinity. You can do whatever you want. All right. Do we have any questions? So you might, they might go through and say, hey, well, what's f of x? Well, that's just taking f of x and plug it in inside itself. So you would take 3x plus 1 and plug it in right there for this x. And then you would simplify. You would take 3 times 3x plus 1 and add 1. Or you might have g of x. You would take x squared and plug it in. X squared is x to the 4th, and you'd be done. So you got to see what they're asking you to do. Usually it's f of g of x, g of f of x, f of x, or g of x. You just got to see what they're looking for. Any questions on 8 and 9, y'all? So a lot of you guys are like, man, that's easy, and I don't need to see any more, but I want to show you these last two for sure, because now we're dealing with fractions. Okay, now this is where domain, really, we need to hit up on domain and make sure we understand it. Okay, so when we do domain of fractions, we definitely have some restrictions here. So again, I'm doing f of x here. In blue, I have f of x equals 2 over x minus 1. And g of x I have is 3 over x. So when I take a look, there's definitely a restriction here. What makes my denominator 0? What's your domain? All reals except for what? What makes x minus 1 0, y'all? Shout it out. What do you think? What makes your denominator 0? Show me your fingers. Just don't give me the middle one back. What do you think? Braden, what do you think? Juan, Dylan, Ariel, what do you guys got? What can you not have? Hank, what do you got? X cannot be what? What makes this guy undefined? What can you not divide by? Mary's giving me the 1. Very good. So if you set x minus 1 can't be 0, right? Can't divide by 0 here. Add the 1 over, we get 1. Perfect. Okay. If I look over here, g of x, I have 3 over x. X can't be 0 either. Okay, so the domain of this guy, x, can't be 0. It can be anything, it just can't be 0. Poor Melody keeps on getting knocked out of here. All right, so any questions on my domain of my two functions that I'm starting with? So far, so good. I hope we're writing this down. Here we go. So I've got f of g of x. G of x is this guy right here. It's 3 over x. Well, if I want to do f of 3, I would take the f function, which is 2 over x minus 1. But instead of x, I would put parentheses and I would put 3 right here. But it's f of g of x. It's f of 3 over x. So I got to put the 3 over x right here. Okay? And now this is where domain comes in. When I do my domain, I got to do my domain of my input and my final output. Well, right now, if I was to check domain, there's a restriction with this guy, right? If you look at my input, the input has a restriction that x can't be 0. So my final answer is domain can't be 0. Because if I plug in 0 right now, this whole thing's undefined. Does that make sense? So when you do domain, check your input and your output. So there's a restriction in my input. Now, we want to simplify this, okay? You can't see me right now, but I'm shaking, all right? My head has a little nervous tick to me, all right? This is like a English teacher in reading one of your handwritten essays, and you're not capitalizing I, and you're not capitalizing the first word in each sentence, and you're not using punctuation, and they'd start shaking, okay? That's what's happening right now at the Gotsch household. I got this nervous tick. I see a fraction, this little guy, inside this big fraction. I can't stand that. We got to simplify that, okay? So for us to do that, we need to get rid of this x on the bottom, okay? Now, this is something that your Algebra 2 teacher taught you way back in March, April, May, somewhere in there, and then ask yourself how much math did you actually do during the first quarantine. I can't answer that for you. You could, okay? But a little trick to simplify this guy is to multiply everything by the denominator. So if we have a denominator right here of x, the little trick, I'll use red here, is to multiply top and bottom by that denominator. Okay, so maybe make note of that, multiply by your denominator. Start that up. Okay, so I'm multiplying top and bottom by my denominator. When I do it to the bottom, I've got to distribute to every term. So I got to just basically multiply everything by that denominator. Okay. Now, when I do that, a little math magic happens. Doo-dee-doo-dee-doo. On top, I get the 2x. X times 2 is 2x. And here's the magic. When I multiply x times 3 over x, doo-dee-doo-dee-doo, these x's eliminate and just disappear. There's the magic. And now we get 3 and then minus x. Negative 1 times x is negative x. And that's my final answer. Look at that. So I multiplied everything by the LCD, which in this case is x. Okay. And x times 2 is 2x. Here the x's cancel. Leaves me with 3 and then minus x. Okay. Now to finish off, you're going to be asked for the domain. I have a restriction of 0 from my input, and now this is my output. This is my final composite. So I have to look at 3 minus x. That can't be 0 either. So when I add the x over, I get 3 can't be x. That doesn't make sense. That's written backwards, right? That's like Yoda. Hard to see the dark side is. 3 cannot be x. Yeah, that's just crazy. It would be x cannot be 3. So x can't be 0 or cannot be 3. There you go. Was my Yoda impression pretty spot on or not so good? Do I need to work on that? Anna, do I need to work on that? No? Mary? Work on Yoda? No? Hard to see the dark side is. Oh, yeah. Oh, man. All right, all right. Any questions with that one, y'all? You guys got a real treat if you're a big Ahsoka Tano fan. And you Star Wars fans, oh, man. The Mandalorian, watch out. All right, let's do 11. We're almost done here, gang. Let's get her up. So when I take a look at number 11, I've got g of f of x. F of x goes in here. F of x is 2 over x minus 1. Okay, so the g function says I take 3 and I divide by my input. So if it was g of 2, I would plug in 2 right here. I'd get 3 halves, right? But it's not g of 2, it's g of 2 over x minus 1. Okay, well, right now, I have a restriction in my domain. My domain is all real numbers, except x cannot be 1. If I plug in 1 right now for my input, if I plug in 1, that's undefined, makes the whole thing undefined. So I can't have that. So when I do domain, I always do domain of my input and then whatever I get at the end. Okay? So, little trick here. I have 3 over 2x minus 1. If it helps you, you could look at it like this. Think of it as 3 over 1 and then divided by 2 over x minus 1. Okay, think of a fraction over fraction. If I have a fraction over fraction, I can multiply by the reciprocal. Okay, back in the day when I learned it, they said, don't ask why, invert and multiply. All right, so I can flippy flip this guy, multiply by the reciprocal, and that way these guys cancel. And I can distribute here. 3 times x is 3x, and 3 times negative 1 is negative 3. And 1 times 2 is just 2. So my final answer is 3x minus 3 all over 2. Hopefully you guys can see that. Finish up with your domain. If I look on the bottom, I don't have an x to solve for. That means I don't have any other restriction in my domain. I just can't have 1. So my domain is all reals except for 1, and that's from the input. The output, my composite function, had no restriction. Okay, but I have to look at my input and my output for my domain. Okay. All right, any questions? Now, there is other ways to solve that one. I'll just do it real quick here. So if you had 3 and then we had 2x minus 1, the other way you could do is just do what we did before, is look at your denominator, x minus 1, and multiply that top and bottom. So that these cancel, and then we just distribute. That gives me 3x minus 3, and then all over 2 is left. You got 2 different ways to look at that. Okay, you can invert and multiply, or you can just multiply by the lowest denominator. All right, ladies and gentlemen, before we get out of here, I do want to talk about number 12. This is a basis of where we're going, so I need to talk about this real quick. Number 12 is saying, hey, show that the 2 composites are equal. Show that f of g of x and g of f of x is equal to each other, which will equal x. All right, so I got to show you this real quick. So I'm going to do f of g of x. G of x is this guy right here, x squared, and f of x is the square root of x. So f of g of x, f of x squared is just, hey, the f function says I take my input and I square root it. My input is x squared. When I square root something squared, I get what's inside, I get x. So I'm halfway done. I got what I wanted. And now I do the other way. I want to do g of f of x. F of x is the square root of x. Well, the g function says I square my input. Well, my input is this guy, the square root of x. And when I square square root, I get what's inside, which is x. So I just showed that these two are equivalent to each other. When I do f of g of x and g of f of x, I get the same thing, which I get as x. Now, this only happens if these two functions are inverses of each other. Okay? And that's the whole premise of what we're going to learn here shortly in the next few sections. we're going to discover and look at exponential and logarithmic functions, and you'll see that exponentials and logs are inverses of each other. And that's actually the next section. We start talking about one-to-one functions and inverse functions. Okay, that's chapter 5 too. So ladies and gentlemen, that's all I have for you today.